Welcome to Math on Ice, December 2011 Integral Equations Part B and C. We do not have any questions from Part B. We have two questions from Part C. Question number 1. For the integral equation u of x is equal to f of x plus lambda times of integral a to b k of x comma t u of t dt to have a continuous solution in the interval a less than or equal to x less than or equal to b, which of the following assumptions are necessary? Kernel not identically equal to 0 is real and continuous in the region a less than or equal to x less than or equal to b, a less than or equal to t less than or equal to b with kernel bounded. And second option is f of x is not identically equal to 0 is real and continuous in the interval a less than or equal to x less than or equal to b in the closed interval a comma b, and lambda is a constant and it should satisfy which is less than 1 divided by m into b minus a, where m is the bound of the kernel and the b is the a to b. So we find the interval b is here and a is here of the interval. So we find yes, from the equation, from the integral equation, we see from the basic definition of the integral equation is that the lambda must be a constant, right? So option C is true for sure. This is true. And kernel, if it is equal to 0, if kernel k of x comma t is equal to 0, then what happens? This is no more an integral equation. An integral equation should have an kernel, non-zero kernel, and this type will give you the integral equation, right? So for the integral equation, if k of x comma t is equal to 0, then in that case, this equation does not exist. So this is a case which is not possible. The kernel should not be identically equal to 0. Is real and continuous in the region a less than or equal to x less than or equal to b, a less than or equal to less than or equal to b with unboundedness. If it is so, this is given in the option, it is boundedness, but let us take if kernel is unbounded. If it is so, this is a Fredholm type integral equation. The limits are fixed. So if the limits are fixed, then the kernel should not be bounded. If it is bounded, then that case is also a does not existing case. So we have this is also not possible. So kernel must not be identically equal to 0 and kernel must be bounded. So option A should be true. And for second option, f of x is not equal to not identically equal to 0 is real and continuous in the interval a less than or equal to x less than or equal to b. If suppose uh, f of x is equal to 0, in that case we get a trivial solution. If f of x is equal to 0, we get the homogeneous type, homogeneous Fredholm integral equation, and we get the Fredholm integral equation having the trivial solution. U of x is equal to 0 will be a solution, obviously, and it may have an extra solution also. A non-trivial solution may also exist. Let us take an example. U of x is equal to lambda times of integral minus 1 to 1 x plus t into y of t dt, and that is equal to lambda minus 1 to 1 x into y of t dt plus lambda integral minus 1 to 1 t into y of t dt. So that is equal to, so I have taken it as y of x. So that is equal to lambda into x into integral minus 1 to 1 y of t dt plus lambda into integral minus 1 to 1 t into y of t dt. So this is what your y of x is. Now this will be y of x is equal to lambda x c1 plus lambda c2, where c1 is equal to integral minus 1 to 1 y of t dt, and we have this c2 is equal to minus 1 to 1 t into y of t dt. Now what is our y of x, which is equal to lambda x c1 plus lambda c2? So c1 will be equal to minus 1 to 1 lambda t c1 plus lambda c2 into dt, and then c2 will be equal to minus 1 to 1 t into lambda t c1 plus lambda c2 into dt. So this is c1 is equal to lambda c1 minus 1 to 1 t into dt plus lambda c2 integral dt, and this c2 will be equal to integral minus 1 to 1 lambda c1 t squared into dt plus integral minus 1 to 1 lambda c2 outside t into dt. Now integral minus a to a f of x dx, if f of x is an odd function, then it will be equal to 0, right? So this part will be equal to 0. Since t is an odd function, it is from minus a to a, minus 1 to 1. So we get the first part to be 0. So we find lambda c2 into, this is also minus 1 to 1. So we find t into minus 1 to 1. Similarly, here c2 will be equal to, this part is equal to 0 since it is minus 1 to 1 integral ft into dt. F is an odd function. So we find this part to an 0. So we find only one first integral. So this is lambda c1 into t cube by 3. The lower limit is minus 1, upper limit is 1. So we find c1 is equal to 2 lambda c2, and then c2 is equal to 2 by 3 lambda c1. So combining these two equations, we find C2 is equal to 2 by 3 lambda. Instead of C1, I'm going to substitute 2 lambda C2. So if we substitute, we get 4 by 3 lambda squared minus 1 into C2 is equal to 0. From this, we get either C2 is equal to 0 or this 4 by 3 lambda squared is equal to 1. If suppose 4 by 3 lambda squared is equal to 1, that implies lambda squared is equal to 3 by 4. That implies lambda is equal to plus or minus root 3 by 2. So lambda can take this value, or else if we can find C2 is equal to 0. If C2 is equal to 0, if C2 is equal to 0, that implies because C2 is equal to 0 means C1 is also 0. C2 is equal to 0 means 2 by 3 lambda C1 is equal to C2. We find C1 is also equal to 0 and we find the solution y of x is equal to lambda x C1 plus lambda C2 is the solution. So we find y of x is equal to 0. So this is a trivial solution. And if we have lambda is equal to plus or minus root 3 by 2. This is for the case when lambda is not equal to plus or minus root 3 by 2. And if lambda is equal to plus or minus root 3 by 2, that implies C1 is equal to C2 is not equal to 0. Okay, wow. So we have found C2 is not equal to 0 and it cannot be, it may not be 0, and this part lambda is equal to plus or minus root 3 by 2. If C2 is not equal to 0, what about the value of C2? C2 is actually equal to 2 by 3 lambda C1, right? So C2 is equal to 2 by 3 lambda C1. So we find y of x is equal to lambda x C1 plus lambda C2. Instead of C2, we find 2 by 3 lambda C1. This is what our solution is. This is a non-trivial solution. Or else instead of lambda C1, we can, instead of lambda C2, we can have C1 divided by 2 also. Lambda C2, we can have C1 instead of lambda C2, we can have C1 by 2. This can be C1 by 2. This can be the solution. And where C1 is an arbitrary number. C1 is arbitrary. If f of x is equal to 0, then we find this solution. Okay, lambda is any constant, right? When lambda is particularly fixed by plus root 3 by 2, we find this solution. This is a continuous solution. And when lambda is equal to minus root 3 by 2, in that case also we find the continuous solution. When lambda is not equal to plus or minus root 3 by 2, in that case y of x is equal to 0 is a solution. So in any of the following ways, we get f of x is not equal to, not identically equal to 0, it's not necessarily. Necessary case is when you are asked to find the unique solution. When in the question unique is asked, then in that case we find f of x should not be identically equal to 0. In that case, this option will become true. Now here uniqueness is not given. So this option B is a false. And then modulus of lambda is less than 1 divided by m into b minus a. Let us find this one. Modulus of lambda is less than 1 divided by b minus a or not. Let us take an example. Y of x is equal to lambda times of 1. Let me take 1 plus lambda times of integral 0 to pi by 2 sine x into y of t dt. So this will be equal to 1 plus lambda times of sine x outside integral 0 to pi by 2 y of t dt. Let me take this part as c. So I'll find y of x is equal to 1 plus lambda c into sine x, where c is equal to integral 0 to pi by 2 y of t dt. And just replace this integral 0 to pi by 2. What is our y of t? This is y of t. 1 plus lambda c into sine t into dt. Now, in particular, this y of pi by 2 is equal to minus 2. This is also taken in the question consideration. Okay, we have given with a question and this particular solution also. So that is equal to integral 0 to pi by 2, 1 plus lambda c sine t. So we find t 0 to pi by 2 plus lambda c into minus cos t into 0 to pi by 2. So that is equal to pi by 2 plus lambda c is the solution. So that implies c minus lambda c is equal to pi by 2. So that implies c into 1 minus lambda is equal to pi by 2, which implies c is equal to pi divided by 2 into 1 minus lambda. Now we get y of x is equal to 1 plus lambda c sine x, right? So that is equal to 1 plus lambda sine x into pi divided by 2 into 1 minus lambda. Also, it is given that y of pi by 2 is equal to minus 1. We have taken the example, right? So y of pi by 2 is equal to minus 1 is equal to 1 plus lambda into sine pi by 2 will give you 1. So this is pi divided by 2 into 1 minus lambda. So minus 2 is equal to lambda pi divided by 2 into 1 minus lambda. So that implies minus 4 into 1 minus lambda is equal to lambda pi. That implies minus 4 plus 4 lambda is equal to lambda pi. We need to find the value of lambda. So 4 lambda minus lambda pi is equal to 4. That implies lambda is equal to 4 divided by 4 minus pi. This is the value of lambda. Now what is your modulus of lambda, which is equal to modulus of 4 divided by 4 minus pi? We need to evaluate whether this is greater than 1 divided by m into b minus a, which is less than. Modulus of lambda is strictly less than 1 divided by m into b minus a or not. We have to verify this. Now here comes the verification. M sin x is your k of x comma t. M is the bound of kernel. Now we have the kernel as sin x. So we find the bound. Upper bound is 1. So modulus of sin x, which is less than or equal to 1. So we get this as 1. So 1 divided by 1 into lower limit and the upper limit. Upper limit is pi by 2, lower limit is 0. So we find pi by 2 minus 0, which is equal to 2 by pi. So this is what our lambda is. Should we verify? We should verify, is this our lambda or not? Now this 4 divided by 4 minus pi is strictly greater than 2 by pi. When you find the value, it is strictly greater than 2 by pi, which is equal to 1 divided by m into b minus a. So we find modulus of lambda is strictly greater than 1 by m into b minus a. But we are asked whether it is modulus of lambda is less than. Now this option is wrong. Now, next question, the integral equation y of x is equal to 1 plus lambda integral 0 to pi by 2 cos of x minus t y of t dt has unique solution or no solution, or whatever be the solution, type of solution. Y of x is equal to 1 plus lambda integral 0 to pi by 2 cos of x minus t into y of t dt. Now here kernel f of x is equal to 1, kernel is equal to cos of x minus t. So k of x comma t is equal to cos a cos b plus sin a sin b. So this is equal to alpha 1, beta 1, alpha 2, beta 2. So alpha 1, beta 1, alpha 2, beta 2. How do we find the solution for this type of equations, questions? Ax is equal to b. Take Ax is equal to b. Find A, x and b matrices. We find the solution one by one. So what is the matrix A? A is equal to 1 minus lambda A11 minus lambda A12 minus lambda A21 and 1 minus lambda A22. And matrix X is equal to, we find C1, C2, which is to be found, and then we find your B is equal to V1, V2. Now, what about your Aij? Aij is equal to integral A to B beta I of x into alpha j of x into dx, and Vj is equal to integral A to B f of x into beta j of x into dx. Now, if we find A11 is equal to integral 0 to pi by 2 alpha 1 beta 1, right, cos x dx, which is equal to integral 0 to pi by 2 cos squared x dx, that is 1 plus cos 2x divided by 2 into dx. When you take the integration, we find 1 by 2 outside, and this is just x 0 pi by 2. This is plus 1 by 4 into sine 2x, which is 0 to pi by 2. So we find this is equal to pi divided by 4 is the answer. Now A12, which is equal to 0 to pi by 2 beta 1 and alpha 2. Beta 1 and alpha 2, which is cos t into sine x. So we get cos x sine x dx, which is equal to integral 0 to pi by 2 sine 2x by 2 into dx, which is equal to minus 1 divided by 4 into cos 2x 0 to pi by 2, which is equal to minus 1 by 4 cos 2 into pi by 2 minus cos 0, which is equal to minus 1 by 4 minus 1, which is equal to 1 by 2. And A21 will be equal to 0 to pi by 2 beta 2 and alpha 1. Beta 2 is sin x, alpha 1 is cos x, so sin x into cos x, same thing we find, which is equal to 1 by 2. And then A22 is equal to integral 0 to pi by 2 beta 2 and alpha 2, which is equal to sin x sin squared x. So we find sin squared x into dx, which is equal to integral 0 to pi by 2 1 minus cos 2x divided by 2 into dx, which is equal to 1 by 2 into x into 0 to pi by 2 minus 1 by 4 into sine 2x, which is equal to 0 to pi by 2, which is equal to 1 by 2 into pi by 2. So we get pi by 4 alone. So the matrix A would be equal to 1 minus lambda pi by 4 minus lambda by 2 minus lambda by 2, 1 minus lambda pi by 4. And we need to verify, find V1 and V2. V1 is equal to integral 0 to pi by 2 f of x. In this problem, f of x is equal to 1. So we get f of x into beta j. So this is 1 into cos x into dx, which is equal to sin x, upper limit and the lower limit. So it will be 1. And V2 is equal to integral 0 to pi by 2, 1 into sin x into dx, which is equal to minus of cos x, a lower limit and the upper limit, which is equal to 1. So we find B matrix is equal to 1 and 1. So in order to find whether this is having a unique solution or not, we need to find the rank of the matrix. If the determinant is not equal to 0, then the rank will be full rank. So we need to find the determinant of the matrix A. Find the determinant of the matrix A. If in the case when lambda is equal to 0, in that case and all, it will not give you the unique solution. When lambda is not equal to 0, we get the unique solution. So find the determinant of the matrix A. We find 1 minus lambda pi by 4 the whole squared minus lambda by 2 the whole squared, which is equal to 0. So we get this as a squared minus b squared, which is equal to 1 minus lambda pi by 4 minus lambda by 2, and then 1 minus lambda pi by 4 plus lambda by 2, which is equal to 0. So either this is equal to 0, so that implies 1 is equal to lambda pi by 4 plus lambda by 2, or we get 1 is equal to lambda pi by 4 minus lambda by 2. So that implies 4 is equal to lambda into pi plus 2, or 4 is equal to lambda into pi minus 2. So we get lambda is equal to 4 divided by pi plus 2, or lambda is equal to 4 divided by pi minus 2. If lambda is equal to 4 divided by pi minus 2, or lambda is equal to 4 divided by pi minus 2, then no solution. So unique solution if lambda is not equal to 4 divided by pi plus 2, or lambda is not equal to 4 divided by pi minus 2. Okay, in both the conditions, unique solution. Okay, if you see the first option, a unique solution for lambda not equal to 4 divided by pi plus 2. So in this case, lambda is equal to 4 divided by pi minus 2 means no unique solution. So this is wrong. And the second option, lambda is equal to 4 divided by pi minus 2. When lambda is equal to 4 divided by pi plus 2 means we get an unique solution, right? So this option is also wrong. So we find no solution for lambda is equal to 4 divided by pi plus 2. So we find this no solution or not. Lambda is equal to, what is the value of lambda? Lambda is equal to 4 divided by pi plus 2. In that case, are we getting no solution or not? 4 divided by pi plus 2. So what is the matrix A? A is equal to 1 minus lambda pi by 4 minus lambda by 2 minus lambda by 2, and 1 minus lambda pi by 4. 1 minus lambda pi by 4 minus lambda by 2 minus lambda by 2, 1 minus lambda pi by 4. So that is equal to 1 minus lambda is equal to 4 divided by pi plus 2 into pi by 4 minus 4 divided by pi plus 2 into 1 by 2, and then minus 4 divided by pi plus 2 into 1 by 2, and then we have this as 1 minus 4 divided by pi plus 2 into pi by 4. So this is equal to 4 cancels each other. Here 4 and 2 cancels each other. And then we find 1 minus pi divided by pi plus 2, and this is minus 2 divided by pi plus 2, and this is minus 2 divided by pi plus 2, and this is 1 minus pi divided by pi plus 2, and that is equal to, when you cross multiply, we get pi plus 2 in the denominator, and we get pi plus 2 and pi cancels each other 2, and this is minus 2 divided by pi plus 2, and then here it is minus 2 divided by pi plus 2, and this is 2 divided by pi plus 2. This matrix is having determinant of A is equal to 0 when lambda is equal to 4 divided by pi plus 2. If lambda is equal to, when lambda is equal to 4 divided by pi plus 2, determinant of A is equal to 0. Right, this is what we found here actually. Lambda is equal to 4 divided by pi plus 2, the determinant will be 0. And we have already verified, but also we have verified again. Okay, now whether it is giving no solution or not. How do we verify this no solution? In order to verify the no solution, we substitute the matrix B. A, B. A augmented matrix with B. So we find the rank of the matrix. Here it is 2 divided by pi plus 2 minus 2 divided by pi plus 2 minus 2 divided by pi plus 2 and then 2 divided by pi plus 2. Augmented matrix is 1 and 1 because we get the matrix B as 1 and 1. V1, V2. So matrix B is 1 and 1. So that is equal to, when you just interchange 2 divided by pi plus 2, adding the row 1 and row 2. Row 2 implies row 1 plus row 2. That is 2 divided by pi plus 2, which is equal to, when you add these two, this will be equal to 0 and this is equal to 1 and this will be 2. Rank of A is equal to 1 and rank of A by B is equal to 2. So both are not equal, therefore no solution. No solution when lambda is equal to 4 divided by pi plus 2. Yes, true. No solution when lambda is equal to 4 divided by pi plus 2. But the corresponding homogeneous equation has non-trivial solutions. Corresponding homogeneous equation. So what is the corresponding homogeneous equation? Now here this is a corresponding homogeneous equation. Homogeneous means this part will be not equal to this part will be not equal to 1 comma 1. Your Ax will be equal to 0. Ax is equal to 0. You have the matrix A matrix whose determinant is equal to 0 and then you have the C1, C2 and this is equal to 0, 0. You will find C1, C2 value also. Okay, you will find if the determinant is not equal to 0, then this is a homogeneous case. If in the homogeneous case the determinant is not equal to 0 means we get unique solution. In the homogeneous case, if the determinant is equal to 0 means we get infinitely many solutions. So we find non-trivial solutions also. Infinitely many solutions means we find non-trivial solution also. So the option C must be true. Third option is true. This must be true. And no solution for lambda is equal to 4 divided by pi minus 2. We know that 4 divided by pi minus 2 is the solution for which the determinant is equal to 0. Right. So when you apply the lambda is equal to 4 divided by pi minus 2, we find the determinant is equal to 0 as like this one. And then we will just verify whether it is having no solution or not. Now, A is actually 1 minus lambda pi by 4 minus lambda by 2. Here it is minus lambda by 2, 1 minus lambda pi by 4. Right. So I have to apply lambda is equal to 4 divided by pi minus 2. So if I apply lambda is equal to 4 divided by pi minus 2, I'll find this matrix as a 0 matrix. That is, it will be a matrix which is having the determinant 0, right? So we find the matrix A is equal to 1 minus lambda is 4 divided by pi minus 2. We find the augmented matrix and then we will just evaluate whether it is having no solution or not. So first we will reduce the matrix A. This 4 divided by pi minus 2 into 1 by 2. And this is minus 4 divided by pi minus 2, 1 by 2. And then this is 1 minus pi by 4 here. 1 minus 4 divided by pi minus 2 into 1 by 2, which is equal to 4 cancels each other. 2 and 4 cancels. Here we get pi by 4. So that is equal to 1 minus pi divided by pi minus 2 minus 2 divided by pi minus 2. This is minus 2 divided by pi minus 2 and this is 1 minus pi divided by pi minus 2, which is equal to pi minus 2 minus pi will cancel each other. We get minus 2 divided by pi minus 2 minus 2 divided by pi minus 2 minus 2 divided by pi minus 2 and then minus 2 divided by pi minus 2. So we find the augmented matrix A by B, which is equal to minus 2 divided by pi minus 2 minus 2 divided by pi minus 2 minus 2 divided by pi minus 2 and then here minus 2 divided by pi minus 2, 1 and 1. So R2 implies R2 minus R1, which is equal to minus 2 by pi minus 2 minus 2 by pi minus 2 and then this will be 1. This is 0, 0, 0. So we get rank of A is equal to 1, which is equal to rank of A by B, therefore infinitely many solution. But in the question solution, infinitely many solution. Okay, but in the option it is given that no solution for lambda is equal to 4 divided by pi minus 2. So the option 4 is wrong. That's it. Thank you.